Okay, Algebra 1, back in Chapter 10 here. We're on Section 10.2b, okay? And so we're going to kind of continue what we're doing, what we did in the last lesson, 10.2a, with simplifying radical expressions. I'm just going to kind of do a couple different things in this one. So continue on where we left off from yesterday. So just remember these three things again. Remember, when we're simplifying radicals, you can't have any perfect square factors of the radicand. We can, if it's perfect square, we can take that square and simplify it. And then here, no radicands have fractions. And then, of course, we don't want any radicals in the denominator of a fraction. Okay, so those are the three things you got to worry about. Yesterday, we talked about this part here, where you go from square root of AB, and you can break that up to b squared to a times square root of b. Today, we're going to kind of look at, we can do the other thing as well. We can go ahead and go the other way. You've got two products, square root of a, square root of b. You can put those together and multiply it to get a times b, and then simplify it. So you can do it either way. We're just going to be able to, we're going to simplify either way, so it doesn't matter if you break them up or if you multiply them together to simplify them. We'll simplify it either way. Okay, so let's do some examples of that. This first one's pretty simple. So you got square root of 12 times square root of 3. Well, if you multiply those, you're going to end up getting 12 times 3, which is the square root of 36. And of course, we know that that's going to simplify to 6. So that one was easy because it was a perfect square. How about one that's not a perfect square? Let's check this one over here, number 2. Square root of 5 times square root of 10. We could multiply those to make it the square root of 50. And then we have to break that one down, okay? So breaking this one down, remember, looking for perfect square factors. So when we're looking for these factors, we don't really care about any other numbers except for that the stuff we had on our chart from our notes yesterday. You know, 1, 4, 9, 16, 25, 36, 49. Those are the numbers we want to look at. If there's not one of those, then we don't want to use it. So we want to use a perfect square here. So 25 is a perfect square, and it's a factor of 50. So we can go to the square root of 25 times the square root of 2. So we multiplied it to get the square root of 50, and then we broke it down again to make 25 times 2. Okay, because 5 and 10 here were not perfect squares, but if we put it together and make 50, and then we can break that down 25 and 2. Okay, so now we know we got a perfect square in 25 to make that 5. Is there anything I can do with the square root of 2? No, so it's just going to stay the square root of 2, and that would be my final answer there, 5 times the square root of 2. Okay, let's do another one. This one has some variables here. So again, we can multiply underneath the radicals. So 6x times 8x would give us 48x squared. So we now have the square root of 48x squared. 6 times 8 being 48, x times x being x squared. So now let's break that up. When we break that up, we're going to have the square root of 48. Let's break up the numbers and variables over here. And then we're going to have the square root of x squared on that side. Okay? So now we're looking for perfect squares of 48. Now, again, look, we know that 6 times 8 equals 48, but those aren't perfect squares. So we want to get a number that's a factor of 48 that's a perfect square. So if we go a little bit higher number, we can get 16, because we can say square root of 16 times the square root of 3. 16 times 3 is 48, so we can do that. And then we know that we have a perfect square with 16. So the square root of 16 is 4. Is there anything we can do with the square root of 3? No, there's nothing we can do with that square root of 3. So it's going to come down into our final answer. I'm going to leave it a little space because we still have to deal with this x squared up here. Okay, don't forget about that x squared. Well, what's the square root of x squared? Or what times what gives us, what times itself would give us x squared? It would be x. So I'm going to shift that thing down here because we want the coefficients outside of the radical. So it'd be 4x times the square root of 3 would be our final answer there. Okay. Let's skip 4 and let's do number 5, another one with radicals in there. And one thing to point out here is that we've got a number outside, right, a coefficient, a 2, and we've got our radicands inside. So we can multiply those, but we want to keep them separate. So you can multiply the coefficients the coefficients. Those are the number outside of the radical. And you can also multiply the radicans, the numbers inside. We talked about that as well. But keep those separate. Don't cross and multiply a coefficient by radicans. Okay, so we can do that, but we want to keep that separate. Okay? Keep them separate. And then you can still do the same properties that we talked about. So let's look at this example. Remember, if there's nothing in front, we assume it's a 1. So our coefficients would be 2 times 1, which is 2. And then the radicans underneath the radical here would be 4a times 9b. Well, 4 times 9 is 36. A times b is a times b. And so that's all underneath this radical. All right, now let's think about what we can do here. Square root of 36, let's break it up a little bit. We know that the square root of, we're going to bring down this 2. We know that the square root of 36, let's put that separate, and then put the square root of a and the square root of b, okay? And we also know that, hey, square root of 36 we know is going to be 6. And don't forget about your 2 here. Sometimes it makes sense to circle it just so you don't forget about it. And we've got that 2 there. So now what do you do with the number outside? And now we've got another number outside with a 6. What are we going to do with that 6 and that 2? Well, remember, if there's no sign between them, that means multiply. So 6 times 2 is going to be 12. And then we've got the square root of a and square root of b. Well, there's nothing we can do there. So we're going to keep them underneath the square root and just keep them together. So 12 times the square root of ab would be our final answer there. Okay, you can work on 6, but again, just talking about keeping your coefficients and radicans separate when you multiply them. In this case, 4 times 3 would give you a 12, and then underneath the radical, your radicans 10 times 6 would be 60. So you can go 12 times the square root of 60, and then break that down. Still needs to break down. That one. Okay. All right, that does it. So we're on to the lesson summary. And remember, you guys gotta fill these out. Okay, sometimes we're slacking and we're not filling this part out. If you want full credit on your notes, you got to fill these out. So how do you simplify the square root of a variable? So we did a couple different examples. You had an x squared. You also had an a and a b. So how do you simplify the square root of a variable? And then lastly, do the practice problem as well, which is square root of 9x times the square root of 8x squared. We're going to break that down, simplify, and get an answer there. Okay? Quick section here, and that'll do it. We'll see you next time.